So the last topic on fractions is going to be kind of some word problems. I didn't want to just hand out the word problems and kind of say, here you go, because I think that we struggle with word problems, and certainly our students do. So I want you to take out the handout that I gave you that's called Fraction Application Problems. And I want us to look at just a few of these and kind of some different ways that you can take word problems and kind of draw pictures that might kind of help you. All right, so let's look at number 1 first. It says 5/8 of the teachers at Smithville Elementary have 5 years teaching experience or less. If 15 have more than 5 years of teaching experience, how many teachers are there at the school? Okay, so first let's start with the 5/8. So you need to come up with some way to show 5/8. Okay, I don't care if it's an area model, but my go-to is usually an area model because I think it's easiest. Okay, so we want to show that 5/8, so we're going to color in 5/8. 5/8 of these teachers have 5 years or less experience. So we can use a different color if we want to, but that means that the remaining teachers must have more than 5 years experience, right? All right, so now notice it says 15 teachers, actual people, have more than 5 years teaching experience. How many teachers must be at that school? So notice we're talking about the people with the more experience, right? So this is 15 teachers. And then because we know we have fractions that are each split up evenly, right? We should know that 15 divided by 3 is going to be 5. In other words, each of these little boxes that I drew represents 5 teachers. Okay, so let me kind of make that darker maybe with my black pen here. I don't think that was that much better. Okay, so what we know now, since these are fractions where we have to have equal size pieces, is that each block represents 5 teachers. So the final question asks us how many teachers were in the school. So notice how many whole blocks are there. There are 8, right? So the total teachers must be 5 times 8. Or 40 teachers. So even if we're not a visual person, pictures can often really help us figure out what the answer should be. Okay, let's look at number 2 on that same worksheet. So it says John spent a quarter of his life as a boy growing up, a sixth of his life in college, a half of his life as a teacher, and then he spent the last 6 years in retirement. Okay, how old was he when he died? So it's always helpful to list what information we know, right? So a quarter of his life, he was a boy. A sixth of his life, he was in college. Half of his life, he was a teacher. And then 6 years, notice we didn't get a fraction here, he was in retirement. Okay, so the first thing we're going to do is we're going to come up with some abbreviations to talk about all of his different stages of life. So for boy, we're going to use capital B. For college, we're going to use C. For teacher, we're going to use T. And obviously retirement, we're going to use R. Okay, so if we want to draw a picture of a fraction, we would need to find the LCD. Like we need some way to relate a fourth and a sixth and a half. Okay, so the lowest common denominator, the first number that 4, 6, and 2 all go into is 12. So we're going to draw an area model with 12 units. Just know that each unit does not represent a year necessarily. Okay, so notice your area models don't have to all be, horizontal boxes. So let's see if we can talk about how we can figure this out. Okay, so we want, I'm going to take the easiest thing first, so I'm going to go kind of out of order here. I'm going to talk about his life as a teacher. Okay, so it would be easy to talk about half of his life, right? So I'm going to fill in half of the boxes, okay, with his life as a teacher. Another way to think of it is, what's half of 6? The answer is 6, right? Or half of 12, sorry. Half of 12 is 6, right? So we filled in 6 boxes. Okay, so using that same strategy, a fourth of his life, so if there are 12 boxes, how would you say a fourth? So divide it by 4, right? So for 3 of the boxes, he was a boy. So I'm just going to say boy, boy, boy. The order really is not important here. Okay, and then a sixth of his life, he was a teacher, or sorry, in college. So if we divide 12 by 6, we get 2, right? So he was in college for 2 of these boxes. Notice that only leaves one stage of life left for him, right? Retirement, so we'll put an R there. And we know for sure that this box represents 6 years of his life. Okay, so because all the pieces have to be the same size, we can do 6 times 12 boxes, right? So it looks like his lifespan was 72 years. Okay, the last one we're going to look at on this worksheet, and then you can look at the last 2 on your own, is number 3. Alright, so you can kind of read through this problem, but this is about a fitness program, okay, and a lot of people signed up for this fitness program on January 2nd, but by March 2nd, some of them had fallen away, okay, and then more had fallen away by May 2nd, and then finally we only had a certain small number of them left on July 2nd, okay. Alright, so the same thing we did on the last problem, let's discuss what these different dates mean. So on January 2nd, they all signed up, but on March 2nd, 4/5 of the original participants were still there. So I'm going to say 4/5 of the original still participating. Okay, the next date of significance is May 2nd. Now notice, this is a little different than the ones before it. If a person drops off before March, if they drop the fitness plan, they're not going to pick it back up, right? So once they're out, they're out. Okay, so we're going to indicate that on our picture. But May 2nd, 5/6 of the remaining were still participating. And then finally, by July 2nd, only 9/10 of the remaining were participating. So what we're going to do is just kind of figure out an LCD, and then we're going to mark out the people or the boxes of people, because likely a box will count for more than one person that we still have here. So first we would need to have an LCD. So the LCD, in other words, how would I relate 4/5, 5/6, 9/10? The first number that all those numbers go into is 30. So I'm going to draw an area model with 30 squares. So let me be clear about what that doesn't mean. It doesn't mean that there were 30 participants. It just means that there are 30 groups of people I'm showing here. Alright, so the box of 30 represents all the people that were originally in the program, okay? But by March 2nd, only 4/5 of them stayed. So notice I have 1, 2, 3, 4, 5 rows. So I'm just going to lightly shade in 5 of those rows. Okay, so these people, I'm going to be dramatic about it, they're out. Okay, they dropped out of the fitness program. So if we want to kind of explain what we're doing, okay, this color right here represents the March 2nd people, the people that stayed in it up until March 2nd. Okay, so now let's go to May 2nd. Okay, and I'm going to pick a little bit darker color. So for the May 2nd people, I'm going to use green. Okay. Now notice, these people have already quit, right? So it's only these people that are left. So how am I going to do 5/6? Well, notice 1, 2, 3, 4, 5, 6 columns, and I only want 5 of those columns. So I'm going to color over 5 of those 6 columns. And then what about the people that are in the boxes that I'm not coloring over with this green color? Okay, what it means is they stayed for March 2nd, but by the time May 2nd come around, they were done, right? So these people are now out. So we have one more date, July 2nd. And I'm going to use a still darker color. Okay, so the question is, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 boxes left, and I need to show 9/10 of them. Okay, so think about that. How could I split 20 boxes into groups of tenths? Okay, that would mean each 1/10 would represent 2 boxes, right? So basically, all except for 2 boxes of people stayed in, because 9/10 is a lot, right? It's honestly probably more than would really actually stick with a fitness plan in real life, since most of the time people don't stick with that, right? So notice I colored in 18 boxes because I had 9 groups of 2 that stayed. And so these people hung out for a while, but now they are also out. Okay, so I guess I need to finish out the problem. I didn't tell you all the information, right? Or we didn't write it down. But notice what it says at the end. On July 2nd, it says that 36 are still participating. Okay, so we have the people that are still participating, right? It's all the boxes that we have not X'd out yet. Okay, so notice we have 18 boxes, right? So if we do 36 divided by 18, we get 2. Okay, so what that means is that each box is 2 people. So the final question says, how many were originally enrolled if there were 36 at the end? Okay, so notice, originally enrolled would be all the people that started, right? So originally we had 2 people per box times 30 boxes, so originally we had 60. Okay, so the thing you want to remember about word problems is they're not to always be intimidated by, first of all, and second of all is they're not always going to be the same. Okay, the point of word problems is to vary the structure and the way that you can show them. So I'm just showing you 3, but to be honest, there'll be homework questions and test questions that won't look exactly like these. But probably some of the methods that I used as far as showing pictures to show those problems would be useful on those kinds of problems. Okay, so remember, word problems are not always cookie cutter type questions. They're often different than questions you've seen before. And we want to teach our students to not be overly intimidated by these as well.